Welcome in everyone. In this video I'm going to go over how to estimate the area without a graph. When I posted my last video, a couple students got a hold of me and said, hey, that last video is fine, but how do you do this without a graph? So here's the video. So for this example, I'm going to be using the function f of x equals x to the fourth power on the interval from 0 to 2, and I'll be using 4 rectangles again. And we're going to estimate this area based on the midpoint of those rectangles. So the first thing you want to do is still find the width of those rectangles. So the width is still going to be b minus a over n. And reminder, a and b come from the interval and n is the number of rectangles. So for this example, it'll be 2 minus 0 over 4, which is just 2 over 4, which is 1/2, or if you like decimals, 0.5. So what that means then is on a number line, what is going to happen is we will start at 0 and we will end at 2, and each rectangle will be 0.5 units wide. So that means I'll come over here to 0.5 or 1/2, 1, 1.5, and 2. So essentially you just count by this number between 0 and 2. Okay, so from there, you would either have to find whether or not you're using the left endpoint, the right endpoint, or the midpoint. And since we're using the midpoint here, well, that means we're going to have to come through here and find the midpoint of each of these 4 different intervals between 0 and 0.5, 0.5 and 1, 1 and 1.5, and 1.5 to 2. So to find the midpoint, you can just take the average of those two values. So if you add 0 and 0.5, divide by 2, you get 0.25. Same thing here, when you add 0.5 and 1 and divide it by 2, you get 0.75. And that's how you find the midpoint for each one here, 1.25 and 1.75. So why do we need the midpoints? Because these values are what we're going to use to find the heights of each of those rectangles. So essentially what I have to do now is I have to go back to f of x, or the function, and substitute 0.25 in for x, substitute 0.75 in for x, substitute 1.25 in for x, and 1.75 in for x. And these will give you a lot of big decimals. You can either use the decimals or the fraction equivalent if you so choose. And we'll end up at the same answer as long as you don't do any rounding. And you'll see pretty quickly here that not rounding probably is not going to be the best idea. So this is the decimal you get when you raise 0.25 to the fourth power. That's, 8 decimal places that you have to keep writing. It's probably going to be better if we go back and just use the fractions instead. So let me get rid of all of these numbers in here. And so you can think of 0.25 as the fraction 1/4. And when you raise 1/4 to the fourth power, you get 1 over 256, which is a lot easier to compute, and you don't have to write out so many decimals. So 0.75 is 3/4, and when you raise 3/4 to the fourth power, you'll get 81 over 256. 1.25 is 5/4, and when you raise that to the fourth power, what do you get? 625 over 256. And look at that pattern starting to emerge. 256 over 256 over 256, because each of these denominators is 4. The denominator over here, after you raise it to the fourth power, will be the same. So the last one here is 7 over 4. That's how you get 1.75. I'd be willing to bet it's over 256, but I'm not quite sure what 7 raised to the 4th power is. 2401. There we go. So those are the heights of all the rectangles. The heights come from function values. And you can look at this one of two ways. We can take this height and multiply it by this width, either 1/2 or 0.5. I think 1/2 might make more sense in this situation. Then we could take this height and multiply by this width, and this height and multiply by this width, and so on. Or we can recognize that each of these will eventually be multiplied by the width, and we can just add all of these together first, and then multiply by 1 over 2 for the width. So when you add all of these heights together, you end up with 3108 all over 256. And then you can multiply that by 1/2. So it would have been this width times 1/2, this width times 1/2, so on, so on. So you can essentially factor out the 1/2, add them all together, and this will give you 3108 divided by 512. And from here, based on what the problem is asking you to do, find it and write it, round it to the nearest hundredth or thousandth or whatever, or write it as a fraction in simplest form. You can do either of those things. So in simplest form, you can divide both the numerator and denominator by 4, or factor out a 4 from the numerator and denominator and cancel them, and you'll end up with 777 all over 128. Or you can divide and then round to the nearest decimal place as needed. This is approximately 6.0703.125, and it's not approximately, it is exactly equal to that. So these areas, units squared, are what you are looking for, and then again, just on the answer, make sure you're using the correct answer for what's being asked. I hope this video helps you out, and I wish you luck.